Good morning, everyone. I'm Leontien, and I'm presenting something that I did during my master's at York. During my master's, I did a work placement at the Archaeology data service, which is a digital archive that holds archaeological data. And one of their biggest collections is their grey literature reports. These are from contract-led archaeology work, and there's a huge variety. So we've got marine archaeology, we've got specialist reports, watching briefs, full excavations. There's everything in there basically. But the library, you can only search for the library with the metadata that's provided by depositors. So sometimes you get very nice metadata. So this is a lovely example where finds and monuments are documented by the depositor. However, sometimes depositors fill in terms such as archaeology, which is not very useful. Also, I decided to work with a subfield in archaeology, zooarchaeology. And that adds another layer of interest because the controlled vocabulary used by the ADS to add this metadata to the report is very limited, very broad. So for zooarchaeologists, animal bone is the only term that will show up in the library. So if you are interested in, say, cattle or rats, you will have to look through all these reports tagged as animal bone. So this led me to see what natural language processing could offer these reports. However, someone suggested to me, why don't you just do a full text search? Really easy, problem solved. However, it's not that easy. There's two problems with it. One of them being that archaeological data is really complicated. So archaeologists have a tendency to tell all these little stories at the start or summarize different sites in the areas, and it leads to a lot of false positives. These are small abstracts from just random archaeological reports, and all the purple underlined terms are false positives. So basically, they're terms that will show up if you would do a full text search, but they actually are not relevant to the research. So for example, in the middle, we have White Horse Stone assemblage. This is not the assemblage that that report actually talks about. Another one is, which a zooarchaeologist pointed out to me, is that he was really interested in rodents. However, there's a lot of terms related to rodents. This word cloud was created from the Wikipedia page for rodents, and just shows the most popular terms for it. So if you would do a full text search, you would be expecting to be looking for all these terms, which is a lot of work. So this led to basically seeing what natural language processing could offer. So natural language processing is a branch of artificial intelligence that deals with interaction between computers and humans using the natural language. The ultimate objective of NLP is to read, decipher, understand, and make sense of the human languages in a manner that is valuable. So basically, the computer starts to understand our language. I'm not the first to do this in archaeology, as Alex is also working on this for Dutch archaeological reports. And previously, there's been other projects that have dealt with this within STAR and Stellar and the Ariadne project. However, all of these tools were rule-based. So rule-based is where you, as a human, write the rules for the computer or for the tagging. So just to give an example of it, we have found birds. So this is all pseudocode. It will actually not work. So if the term bird is found, then tag is true. And then another example would be, we have not found birds. And if that would be found with the term not in the sentence, then you could tag it as false. But you can understand that if we go back to this complicated false positive data, that's a lot of rules you will be writing and a lot of variations. So that doesn't really work. So instead of using rule-based, we decided to use machine learning because it offers a lot more flexibility, because we will not be writing the rules, but the machine will be learning from it and tagging it. Another thing is the relevancy to archaeologists. So a lot of these tools are created in isolation without a lot of input from archaeologists, and that leads to tools that are not very useful, basically. So we decided to set up more of an interdisciplinary team. So we had 2 computer scientists, someone from the ADS, a zooarchaeologist, and me. And I kind of was like this intermediate person that could translate what the limitations were from a computer scientist point of view, but also translate what the zooarchaeologist actually wanted to something that the computer scientist could understand. And another thing is linked data, which is good. And most projects and old projects have used it. But as I pointed out before, it's not granular enough for the zooarchaeological data. So we decided on using the Encyclopedia of Life. And their goal is to tag all species in the whole world. So it's great because there's a lot of data in it and a good ontology. Also, within machine learning, there's deep neural networks, and this is the method that we decided on using. So just to give like a brief explanation of what it actually is, so on the left hand side we've got an input, in the middle we've got a node, and on the right hand side we've got an output. Basically, there's a threshold value in the node. If your input goes over that threshold value, your output will be positive. If it doesn't, it's negative. This is just a neural network. A deep neural network has multiple nodes in the middle called hidden layers. And I just really quickly wanted to show the one that we built. So I'm not going to go into huge detail into this, but I do want to point out a few things. At the bottom, there's a layer with EMB on it. These are all word embeddings. So we as a human are able to distinguish that beforehand. As example, a car would be closer related to, say, a bus than a car is to a flower. A computer's not able to do that, but with the help of word embeddings, it gets a better context of what's happening. The 2 layers in the middle, the units, stand for long-term, short-term memory. This is a model introduced in 2015 in the computer science field, and basically it gives the option of having a lot of data in between that's not relevant. So for example, an archaeological report could have a tag, say cattle, at the start of it, and somewhere, say in the middle of the report, but all that data in between is basically noise and not relevant. And a lot of models before this find that really difficult to handle that like absence of data in between. So this like offers an option of dealing with that. But why use a deep neural network? It's a complicated thing to build. It takes a long time to train. However, within archaeology, as most of you know, we've got small data sets, small complicated data sets with noise in them. And this deep neural network can work with a really small data set that's complicated and still give good results. So that's basically what we want. so now we've got this shiny model that we have to put data into. So we created annotated zooarchaeological data. We did it by picking 5 zooarchaeological reports. So we didn't just pick random excavation reports. We specifically picked zooarchaeological reports, and we did that because then we would have more tags. Then it's annotated by 2 people. This is really important because if you as one person would be tagging it, it could become very subjective. And then these 2 taggings, or 2 tagged reports, are checked by a super annotator for discrepancies between the annotators. Our super annotator in our project was the zooarchaeologist, because he was the most knowledgeable on zooarchaeological data. The reports that were tagged had to be translated to XML because a machine can't read color-coded Word documents. Would be great, but it doesn't. And then this XML was ready to be imported into the neural network. This is just to give you an idea of what the tags look like. So on the right-hand side, you have the color codes. In the middle, you have the name within the Encyclopedia of Life. And on the left-hand side, it's the identifier within the Encyclopedia of Life. And the tagging was done within Gate, because it gives a nice interface for doing it. This is something that computer scientists love. This is the F measure. So when working with computer scientists, they really like this measure. It basically measures the accuracy of the tool. But it doesn't answer that question of relevancy. But I just wanted to point out that our computer scientist, the one at the bottom, the EBLCM, that's our neural network. The one above it is conditional random fields, which is another type of machine learning. And they just really like it that this tool is performing better than conditional random fields. However, it really doesn't answer this question. Well, is it relevant to archaeologists? So because we had a zooarchaeologist in the whole process with us, we kept asking him what he wanted and what he, how he would want to use this data. And at the end, we decided to set up kind of a prototype interface to give him an idea of what would be possible. So for this, we took all the reports from the ADS. We also decided just to include all the PDF reports within the library. So we got about 110,000 reports. Then we did some pre-processing. That was the tagging of the reports. It went into the neural network, and then we merged it with the metadata that was already existing in the library, and that led to a database. We first had this great idea where we would do like the running of the neural network on the fly. So if you would type something in, it would start running. Then we found out it took 23 hours, and no one really wants to wait 23 hours for their results. So we decided to put it into a database. But if the neural network was to be updated, or if annotated data would be updated, of course we will rerun the neural network and update the database. So I think this should work. Yeah, it does. Just to give you a really quick idea of what the interface is like. So you can select an animal, and you can also type in the Latin name if you're really interested in doing that. So as example, if you pick horse and you search, you will see on the side all the metadata that is from the ADS library, and on the right hand side you will see the reports that we extracted. And then if you click on the term horse, it will take you into the Encyclopedia of Life, which is the ontology that we use for tagging. This will give you some extra information on it. You can also go into the names, so that will give you all the synonyms that you have. And at the bottom of this, there's also the taxonomy. So what family it belongs to, and that whole kind of hierarchy. So we decided to incorporate this taxonomy into our system. So yeah, this is just the example of it. So if you go back to the search, sorry, I pre-filmed it, so you can also see that one of the families within a horse is the mammal. So if you go back to your interface and you were to type in mammal, you also get all the terms within that family. So mammals, field mice, sheep, horse, everything like that. So we use that linked data and that ontology to create this. We didn't do this manually. Just to point out some feature work, the one thing with this deep neural network that is a bit negative is that it will only find terms that have been tagged in the annotated data. So it is limited in that way. However, it is flexible. It's a very flexible tool. So it's not created only for archaeological data. You could give it any annotated text data. At the moment, at the ADS, they're seeing if it could be incorporated into their system. So their current ADS library system, to see if it could tag more stuff when these reports come in, which is very positive because this interface is a very bespoke system and you don't just want it to disappear, basically. And another interesting thing is that at the moment I'm doing a collaborative PhD at UCL in the National Archives, and the National Archives are also very interested in seeing what this tool could offer them. So that's archival material instead of archaeological material. Now, that was me. Thank you for listening. And are there any questions?